For today's class, we will continue first chapter, fundamentals. So, like next week, we have learned about a set. Okay. So for today, we will continue with sequence. Okay, sequences and series. Okay. So firstly, we go to the definitions of the sequence. Sequence is a discrete structure used to represent an ordered list. Okay, so if you see here, so the keyword is ordered list. Ordered list. Okay, so it means that we have several elements which is represented in list. Okay, so like this one, we have B1, B2, B3, and so on. 12, 13 over 2, 14 over 3, and so on. So these are the ordered lists, okay, or the sequences. Okay, the list of the terms of this sequence is given by this one. Okay, the sequence delta n, where delta n is equal to 3 to the power of n, can be listed in sequences if n start from 0. Okay, we will have the sequence start with 1, because 3 to the power of 0 will be 1. And then for n equal to 1, the delta 1 will be 3. N equal to 2, delta 2 will be equal to 9. So this will be 1, 3, 9, 27, and so on. Okay, so these are this is sequence. Okay, for we have several types of sequence. One of them is explicit formula. Okay, for the explicit formula, this is the example. Okay, the n is equal to 5 to the power of n. So when n is equal to 0, it will be 1, 1, 5, 25, and so on. Okay, and then for the recursive formula, for the recursive means that for the next list, it will depend on the previous list. Okay, like this one, we have dn is equal to dn minus 1 plus 5. So the value for the dn, which is the current n, will depends on the value for the previous n. Okay, so let's have d0 equal to 3. This one should be comma instead of dot. Okay, so if d0 equal to 3, okay, if d0 is equal to 3, then the d1 for the d1 will be 3 plus 5. Okay, so you notice that the value for dn sub index n minus 1 is the previous value for d0. Okay, it gives you d1 equal to 8. Okay, and then for d2, the dn minus 1 will be the d1, which is 8. 8 plus 5 equals to 13. Okay, so that is recursive or recurrence. Okay, and then we have arithmetic sequence. Okay, for the arithmetic, the initial term A, we have the initial terms A, and then the common difference D. So this is the common difference D. So that is how we construct the arithmetic sequence. For the example, we have Gn is equal to negative 1 plus 4n. So here, A is equal to negative 1, and then the D is equal to 4. Okay, and this is the sequence. Okay, and then we have geometric sequence. Okay, for the geometric sequence, Tn equal to AR to the power of n, where A, because R to the power of 0, it gives you 0. Sorry, R to the power of 0, it gives you 1. So that's why we start with A. So the first element will be A. Okay, and then you have A, comma, AR to the power of 2, AR to the power of 3, and so on. Okay, so A is the initial term, and the common ratio is represented by this R, and it is a real number. Okay, it's a real number. So what is the question, Afiq?
I want to ask for the.
Tn,
Can you hear me?
Tn is equal to A plus ND. No. What do you mean by not? Oh, what is the question, Afiq?
I want to ask for the arithmetic sequence. The formula is Tn equal to A plus N minus 1, right? Or atau saya salah? Sepatutnya A plus ND.
A, apa Afiq? A minus 1? Apa?
Tn equal to A plus N minus 1D. Untuk arithmetic
N
sequence bukan N minus 1 ke?
What do you mean by N minus 1?
For the Tn yang kita nak cari. Maksud saya, setiap Tn kita nak cari, bukankah formulanya ialah Tn sama dengan A tambah N tolak 1D?
N tolak 1 tu, what do you mean? Is it super index or what? Sub index?
Sub index. Maksudnya N yang kecil, N minus 1.
If you look at this example, it is correct because Gn is equal to negative 1 plus 4n. If you substitute n equal to 0 here, it will give you negative 1 as the first element. And then when n is equal to 1, it will give you 4 minus 1. So this is correct. The formula is correct. Okay.
Okay, Doctor. Thank you.
Okay, and then we go to Fibonacci sequence. Okay. Fibonacci sequence F0, F1, F2 is defined by initial conditions F0 equal to 0, F1 equal to 1, and the sequence Fn equal to Fn minus 1, F subindex n minus 1 plus F subindex n minus 2. So if you look at here, you know that the Fibonacci sequence is actually parts of this recursive formula types, okay? Because it depends on the previous values, okay? Find the Fibonacci numbers, F subindex 3. So F2 is equal to F1 plus F0. It will give you 1 plus 0 based on this value here, the value given here. And so F2 is equal to 1. And then F3 is equal to F2 plus F1, which give you 1 plus 1, which is equal to 2. Okay. And then we go to the next one, which is series. So we already covered the sequence. So there is the difference, difference between a series and sequence. Okay, they are not the same. For this series, we have the summation. We will have the summation of each element in the sequence. Okay, so that's why we will have this notation. So this notation is presented for the sum. Okay, so AJ, summation AJ, J start from 0 up to N. So it will give you A0 plus A1 plus A2 plus A plus and so on up to AN. So it will stop at n. Okay, instead of a comma in the sequence, we will have plus for the series. Okay, and then so this is for the summation of omega to the power of 2. For omega start from 1 up to 5. So we will have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. It gives us 55. And then this is negative 1 to the power of a. The series start from a equal to 6 up to 10. So it doesn't always a here will start from 0 or 1. It will depends on this symbol of sigma. If it says it start from 6, then it means that this one will start from a equal to 6, negative 1 to the power of 6 plus negative 1 to the power of 7 plus negative 1 to the power of 8 and so on. Up to negative 1 to the power of 10. Okay. I think that's it. And then we have two types of series. One is finite series. For the finite series, the summation will stop based on this number, yeah, the upper value on the sigma symbol. But for the infinite series, you will have infinity here. Okay, so that's why when you write the infinite series, you will have the plus dot dot dot. It means that will continues. Okay, so that's it about finite and infinite series. And then we have what? So these are some theorems related to series. Okay, let A B is in Z. So Z is an integer. Sn, comma Tn be any sequences, and C is in R. Okay, therefore Sj plus Tj, this is the series, the sigma symbol. It start from J equal to A up to B will be, so what they want to show us here is we can actually segregate. It means that we can pecahkan, segregates these two series, this series, the summation of this series into two separate series. Okay, as a series of Sj and then another one, the series of Tj. Okay, for C, Sj, if we have a real number C here, C can always be taken out from the symbol sigma. Okay, and then for the basic series, if you have the summation, I start from 1 up to n, and the elements is equal to 1. If you have this summation, if you try to sum up 1 up to n times, what you will have? Obviously, you will have n, isn't it? If I say, what will be the summation for the element 1? 4 times. 4 times. You add up 1 for 4 times. 1 plus 1 plus 1 plus 1. So you will get 4, isn't it? So this is that is the same if you generalize the 4 as n. Okay, so the summation start from 1 up to n. So the summation will give you n, regardless the value of n. If n here is equal to 100, then the value will be 100. Is that okay? Okay, and then for this one, these are the formulas. I think you have seen this in your calculus. It is a very important formula. I suggest you to remember this these four formulas. So for the summation I start from 1 up to n. The formula will be n to the power, n multiplied with n plus 1 divided by 2. Okay. Let's say I ask you to sum up the number from 1, 2, 3 up to 10. Can you give me the answer instantly without having to calculate by using calculator? Okay, you can just use this formula. It means that the n will be 10, isn't it? Because I asked you to sum up I from 1 up to 10. So 1 plus 2 plus 3 plus 4 and so on up to 10. So the n here will be 10. So 10 multiplied with 11 will give you 110. You divide with 2, it will give you 55. Okay, you can check with the calculator. It will give you 55. Is it okay? Okay, guys? Okay. Summation I squared. I have to write it down, right? No response is can give me two meanings. One is all the students can understand, and the other one is no one understand. So I think let's write something. I explain again for this one. Okay. Let's say I ask you to sum up 1 plus 2 plus 3 and so on up to 10. So what will be the answer? So the answer relies on this formula. So the n for this series is equal to 10. So that's why you have to substitute n equal to 10 in this formula. So 10 multiplied with 11 divided by 2. So 110 divided by 2 will give you 55. So that's why the answer is 55. You can check with the calculator what will be the value. If you sum up all these values, I'm sure it will give you 55. The same as when you use the formula. Okay. And then if you have I squared, I start from 1 up to n. So for the series here, if you start from 1, it will give 1. And then what will be the value when you have I equal to 2? So it will give you what? 2 squared. 1 squared equal to 1. 2 squared will give you 4. 3 squared will give you 9, and so on. Okay? Up to n. And so this is still finite. If it is infinite, then you will have infinity. Okay, 1, 4, 9, and so on. So the formula will be n multiplied with n plus 1 multiplied with 2n plus 1 divided by 6. Okay. So if you have n equal to, let's say, only 4. So if you have n equal to 4, the formula here will be 4 multiplied with 5 multiplied with 8 plus 9 plus 1 equal to 9 divided by 6. So that will be the value. Okay? Boleh? And then this is the summation for I cube. And then I think this is what? I to the power of n plus 1 divided by 1 r to the power of I. Instead of I to the power of something, okay, the other three series is for I to the power of something, I to the power of an integer. This is integer 1, this is integer 2, and this is integer 3. But for the fourth one here, the formula is when the index, the super index, is actually equal to di itself. Okay, so r to the power of I. So if you have I equal to 0, it will give you what? R to the power of 0. So it starts from R, and then R to the power of, R to the power of 0, it will give you 0. R to the power of 0, it will give you 1. R to the power of 1, it gives you R, and then R to the power of 2, R to the power of 3, and so on, up to R to the power of n. Okay, so and then if you have n equal to 3, so let's just choose n equal to 3 here. Let's decide that n is equal to 3. So your series will be up to this one. Okay. If you sum up this, you will have what? R to the power of 5. 3. R to the power of 4 minus 1. R to the power of 4 minus 1 divided by R minus 1. I think you have to do some factorization in order to get this one, but this is somehow will be equal to this one. Okay. And then type of series. I think this is also the example. Okay. The questions ask for the summation of 2i squared plus I plus 3. Okay. So for this kind of question, you can actually use the previous formula. One is for I squared. Another one is for I to the power of 1. And then for these two, you know that the C can always be taken out from the sigma symbol. Okay, so that's why you have here 2 is taken out from the sigma symbol. What you have is summation of I squared. Okay, and for this one here, you know that you can segregate from the previous theorems. You can segregate the series, so it will stand as a own series. So plus sigma I start from 1 up to n, and then plus the 3 can be taken out. Okay, what is left will be the summation of 1 I start from 1 up to n. So this one will give you 3n. Okay, because this part will be n. Okay, and this one, based on the formula, it will give you this formula here. Okay, and for this one, okay, without the 2, okay, without the 2 will give you this formula. And then of course you have to write the 2 as the multiplier for this formula. Okay, and then next example, find the summation of 3i. So for this one, the I is as the index, okay, super index, 3 to the power of I. So we have to use the previous formula, this formula, okay. There is no solution. You can do it at home. Okay, this is the solution. Yeah, the solution, yeah. So this is the solution. You can compare with this formula. I think it's quite straightforward. Okay, for B, I start from 5 instead of I start from 0. If I start from 0, you know that you can take the answer straight away from this formula. But then for B here, instead of I start from 0, it's somehow given that I start from 5. Okay, so what you need to do is to apply this kind of formula, which is I start from 5 up to n is actually equal to j start from 0 up to j equal to n minus 1. Okay, so somehow you manipulate the value so that the index for the sigma is not I anymore, but then you choose another one, which is j. The j start from 0 and it's somehow not an at n, but it will end at n minus 5. Okay, and then obviously you can do it by representing this formula. The j is equal to I minus 5. So from this, not only that the index for the sigma will change, but also the index for the elements. Okay, the elements is the original one is 3 to the power of I, but because we have I is equal to j plus 1, so that's why when the index is in terms of j, it will be 3 to the power of j plus 5. Okay, and then the 3j, the 3 to the power of j plus 5, you know that it's always can be written as 3j multiplied with 3 to the power of 5. You can put the 3 to the power of 5 in front of the sigma because it's just a real number, C, or a multiplier. Okay, a multiplier that doesn't depends on any j or any index I or whatsoever. Okay, so you can always taken out the 3 to the power of 5. Okay, and then this one, if you look at the formula, you know that you can apply this formula straight away. Okay, but now instead of n as the stopping values, you will have n minus 5. So the value will be 3n minus 5 plus 1 minus 1 divided by 3 minus 1. Okay. And then this is the final solution. Okay, you can still use this formula, but then you have to manipulate the value for this one, for this stopping value of n. But you have, instead of n, you have here n minus 5. Is it okay? Is it clear? Okay. Boleh ah? Boleh siapa ni? Siti Zubaida, okay? Anish Shazwani, okay?
Okey, Doktor.
Dia lemah aja jawab tu. Kenapa? Susah ke? Ahmad Syafiq?
Oh, okay.
InsyaAllah. Alia Shazwani.
Okey, Doktor.
Cia Sri.
Okey, Doktor.
Okay. Khairul Syafiq, okay tak? Okay tak? Okay, we have another slide to finish, okay? Okay, and then we go to the matrices. Okay, we finish about series and sequences. Okay, let's go to the matrices. Okay, a matrix is a rectangular array of numbers. Okay, so the word here is rectangular. It doesn't say square. Okay, because you can always have n times n. Can you please mute your microphone, siapa tu. Okay, you can always have n times m instead of on n times n. Okay, so that's why the words here says rectangular. Okay, a matrix with m rows and n column is called m times n matrix. Okay, m times n matrix. A matrix with the same number of rows as column is called square. Okay, it will be square matrix when you have the number of rows and the number of column are equal. Okay, and then the two matrices are equal if they have the same number of rows and the same number of column. Okay, and the corresponding entries in every positions are equal. Okay, the two matrices are equal. So it means that A is equal to B if A and B are both, let's say, n times n matrix, and B is also n times n matrix. Not only the columns and the rows are equal, but then the elements. So let's say you have 1, 2, 3, 4. Okay, so the elements for each uh, of the elements in A is actually equal to each element in B. So for B, you have 1, 2, 3, 4 as well. Okay. So this is for n times. This is for 2 times 2 matrix. 2 times 2 matrix. Okay. So if for one element, let's say you have here 1, 2, 3, 4. But for B, you have 1, 3, 3, 4. Instead of 2, you have 3 here. Then it won't be equal for the matrix A and B. Okay, even though the size for the matrix A and B are equal, but not that the elements. The element for each of the matrix, the element for the matrix A and B must be equal for each of them. Okay. Okay, and then for the matrices addition, okay, for the matrices addition, you can just add up. In order to do this this addition process, you need to make sure that the size for the matrix A and B are the same. So for this case, you have 3 times 3. For the matrix B, it must be 3 times 3 as well. You cannot that the matrix A is 3 times 3, but then the matrix B is 4 times 4. So for that case, you cannot add or sum up the two matrices. Okay. You must make sure that the size for the matrices are equal. Okay, for the addition process, you can just add up the corresponding elements. So like for this one here, it must be add up with this element, and for this one, for this element here, you must add up with this one, 0 here. And this one here, you have to sum up with this one. Okay, so that is addition. Additions and subtractions, they are almost the same, except that you, instead of plus, you now have to subtract. But then the size for the two matrices must be the same. Okay, for the matrices product, okay, for the matrices product, it must satisfy that, let's say this is 3 times 2 matrices, the B is what? 2 times 3, okay? Here, this one, the row for the matrix for the one matrix must be equal to the column with another matrix. Okay, they must be equal. So in this case, the two here are equal, okay? Then you can do the product. Okay, saya rasa semua this is just revision. Okay, then identity, for the identity, it means that the elements for the diagonal matrix are 1, but then the other elements except other than the diagonal will be 0. Okay. Okay, so this is I3, so 1, 1, 1, and then the other element other than the diagonal elements will be 0. Okay, and then for the matrix transpose, if B is 0, 1, 1, 0, 1, 0, if you transpose the matrix B, it will be 0, 1, 0, 1, 1, 0, 1, 0. You change the column with, you interchange the row and column. Okay. For the sequence, it's called symmetric. Symmetric if A is equal to A transpose. Okay. If A is this one, if you transpose the matrix A, you will get this. And if you not, the matrices for A and A transpose are actually equal. It means that each element in matrix A and each element in matrix A plus, okay, are equal with each other. So we call this kind of matrix as symmetric matrix. Okay. And then 0, 1 matrix, okay, for the 0, 1 matrix. A matrix, all of whose entries are either 0 or 1 is called a 0-1 matrix. So the elements are either 1 or 0. Algorithm using this structure are based on the Boolean arithmetic with 0, 1 matrices. This arithmetic is based on the Boolean operations. Okay, I don't know how to call this symbol, but this symbol is actually, it will act just like union and intersection. Okay, so this is for the union and this is like for the intersection. Just like when you use for the set, if you still remember. Okay, but somehow this symbol will act on matrix only. Okay, and then you have like A is equal to these matrices and B is this matrices, Bm times M0, 1 matrices. Then the join of A and B is the 0, 1 matrix with Ij, the entry of Aij union Bij. The join is denoted as this one, okay. The mid is denoted by this one. Okay, so this is the keyword. So the mid is denoted by this one, and this is the join, denoted by this one. Okay, let's try to solve this problem. Okay. Okay, you have this notation, this definition for the join and mid, defined as follows. Okay, it is the join of C1 and C2 is equal to 1 if C1 is equal to 1 or C2 is equal to 1. Okay, and it is equal to 0 otherwise. So like I said before, this act like union. If you have a union, the keyword is or, isn't it? So that's why you have here words or. But here, C1 intersect Cj or C1 mid Cj here, sorry, C2, C1 meet C2, the keyword will be n. So that's why C1 is equal to 1 and C2 is equal to 1. It's the same as this statement. Okay, so these are the two things about the join and meet that you have to remember. Okay, and then for the final, sorry, is it already final? You still have two slides. Two slides. Find the join and meet of the 0, 1 matrices. So the A matrix is given by this, and the B matrix is given by this one. So A join B, A join B is given by this matrices, and B is given by this one. Ada jawapan tak? Ada ni tak? Ada solution Okay, it's okay. Let's try. Okay, C1 union C2. If you look at here, C1 union 1 union 0. It's or, isn't it? So the answer will be 1. Okay, based on this. For the first element. And then for the second element, 0. The second element for A will be 0. For the second element of B is equal to 1. You have to make sure that they are both sorry, the keyword is or. So one of them is 1. So that's why you can put 1 here. Okay, and then for this one, 1 here and this 0. So either one of them must be 1. So that's why you can put 1. Okay, and this for the fourth element, 0 and 1. So either one of them is 1. So that's why you can put here 1. Okay, and then 1 1, that's why you give it give you 1. For 0 and 0, obviously it will give you 0. So that's why for A join B, this is the answer. But then for A meet B, you know that the keyword is n. So 1 0 must be 0. Okay, because not both of them are 1. Okay, one is 1, another one is 0. So that's why you put it for the answer for the first element is 0, 0 1 0, 1 0 0 again, 0 1 0. But for the fifth one, both of them are 1. Both of them are 1. So that's why you can put 1 here. Is it okay? Okay, and then for the last one, 0 and 0. So the answer is 0. Boleh faham kah? Is it okay? Faham, Fazlina? Okay.
Faham.
Faham, Okay, let's go to the Boolean products. Okay, Boolean products will be, will use the combination of meet and join. Okay, join and meet. This is join and this is meet. Okay. You have to use this formula. The formula is given by this. Okay, let's have the Boolean product between A and B. Okay, 1 0 1 1 0 0 1 1 0, and the B is 1 1 0 0 1 1. Okay, so based on this, you know that for I equal to 1, okay, I, j, and 3 were let's denote them. 1 and 1. This is meet. I meet 1. 1 meet 1. Union is for join. Join 0. 0 meet. This is what? This is join. This symbol is join. This is meet. So if you look at here, 1, 1, 1 because you multiply. You multiply it for the product. You have to multiply this, and then you plus with 0 and 0, isn't it? Okay. When you plus, you have to use this notation, the meet notation. But then for the multiplication, 1, 1, you have to use the meet symbol. Okay, so that's why this is the symbol. Okay, so once you get all the representation based on meet and join, you can find each of the elements. So let's look at this one. 1 and 1, 1 and 1. So this is the symbol for the intersection. It means that it must be both of them. So the answer will be 1. Union 0, 0. So it will give you 0, isn't it? 0. Union 0. So either one of them. So that's why the answer is 1. Okay. What about the second one? 1, 0, 1, 1. 1, 1. It will give you 1. 1. 1. You have n for this symbol, n, so 1, and then union 0 and 1. 0 and 1, it must be 0, isn't it? So that's why the answer will be again 1 union 0. It will give you 1. Okay, and then for the third element, 1 and 0, 1 and 0 for n or for meet. Okay, so it will give you 0, isn't it? It give you 0, and then you have union for 0 and 1. It will give you 0. So 0 union 0, it give you 0. Okay, boleh faham eh? Boleh faham tak? Khairul Syafiq boleh faham tak? Afiq boleh? Mimi Natasha okey tak? Ke tak faham?
Okey, doktor. Faham, doktor.
Faham kan? Okey. Dan nak ambil yang ni satu ni je. Dia kata apa ni? Ni power lah. Power sampai R times lah. Let A boolean product. So for power A to the power of R ataupun A to the power of 5, it means that A boolean product A boolean product A ni sampai 5 kali lah. Sampai 5 kali. Okay. So you kena buat satu lah. This is quite this is not as straightforward as shown. I think you have to do A2 first, isn't it? Kita buat A2 dulu kan? A2 is A boolean product A first. Okay, so you have to take the boolean products of the matrix A and the matrix A. Oops. The matrix A and the matrix A. And then after that, you will have A3, which is A boolean products A, and then another one. So I think you will have like 5 times. Okay, 4 times lah, 4 times. Because this is the first time. Okay, boleh. Okay, I think that's it. Huh? That's it. It's settled our first chapter. If we look at the course planning, Dr. Zila said that I have to cover the first chapter before week 4. So for week 4, we should start with chapter 2. Okay, and then you will have quiz. You have quiz after week 5, or maybe during week 5. Okay, is it okay? Boleh ah? Ada apa nak tanya tak? Any question? Amin, Muhammad Amin. Ada tak nak tanya? Atiwa? Nur Atiwa?
Tak ada, Doktor.
Boleh faham ni? Boleh baca balik? Okay, so kalau tak ada apa, kita bersurai lah. Boleh, apa orang kata, boleh tengok balik lah apa yang kita dah belajar. So, kalau tengokkan ni tak ada apa lah kan, tak ada apa sangat. For first chapter tak ada apa. So, we have 3 subtopic: set, matrices, and sequence and series. Okay, I think that's it. So, thank you very much. So, I end the recording. Okay, I end the recording. And